Hi and welcome to this presentation by the Maths Engineer. In this lesson we will continue our study on kinematics and we'll be considering the motion of a projectile. So what is special about the motion of a projectile? Well, a projectile is any object that is under the sole influence of gravity and follows a curved parabolic path called a trajectory. It requires an initial force to start the motion, with the force of the air resistance neglected in a basic analysis. Now, there is a major difference in the analysis when compared with objects moving solely in the horizontal plane. Because of the angular nature of the trajectory, we must split the motion into vertical and horizontal parts. Therefore, we will call upon the trigonometric functions sine and cosine. For the analysis in the vertical direction, we use sine, and for the horizontal, we use cosine, as we can see in the graph at the bottom here. So, for example, say we were given an initial velocity u that moves in the line of the angle alpha. We would therefore write down our u velocity, u, the horizontal component, u cos alpha, and our vertical component, u sine alpha. Also, a key consideration is to know that at the peak of the trajectory, that is the highest point, roughly in the central centre here, the velocity v equals 0. For the horizontal component travelling in this direction, the acceleration a also equals 0. And for the vertical component, the acceleration due to gravity g is always downwards. A equals g equals minus 9.81 meters per second squared. So with all that has been stated, let's move on to some examples. So to our first problem. A golfer strikes a ball that begins its motion at 60 degrees to the horizontal. The force of the club on the ball propels it at a velocity of 25 meters per second. Find the maximum height that the ball reaches. So as before, let us write down our variables. So we have s equals h, because h is the distance to the top. U equals 25 sine 60, because if you see in the diagram, the ball's hit at 25 meters per second and we need the vertical component for our calculation. V equals 0, because the ball at the top rests instantaneously and so comes to 0. A equals the acceleration due to gravity, which is minus 9.81, and t, we don't need t, so we just leave that as a question mark. So let's look at our Suvat equations down here and decide which one we want to use for our calculation. So we have u, v, a and s. So looking at these 5 equations, the most suitable one to use would be the second one here. V squared equals u squared plus 2as. So let's write that down. So we have v squared equals u squared plus 2as. Let's plug in our numbers. So this is 0 squared equals 25 sine 60 all squared plus 2 times, it's negative because gravity is pulling it downwards, so negative 9.81, and we just replace the s with a h. So cleaning this up, we would have 0 equals, so 25 sine 60 squared gives us 468.75. Sorry, no, it's going to be a negative. 2 times negative 9.81 is negative 19.62h. So let's add 19.62h to both sides. Gives us 19.62h equals 46875. Now let's divide both sides by 19.62 to get rid of that on the left hand side. 19.62. They cancel, so we're left with h equals, do this in the calculator by all means, 23.9 meters. So the distance h here is 23.9 meters, and that's our first problem done.